Welcome to the May 27th HBRC virtual meeting. My name is Chris Mayer, the president of the club, and thank you all for joining. The format is going to be pretty much the same as it was last month. Start off with any robot-related news, followed by showing off robots. Hopefully you have a robot to show off, and you can get that on your camera. If you do have a robot to show, please, like Ralph there and Camp, go to the chat and let us know that you have a robot so that Arthur can take turns giving you the spotlight. After that, we're going to have a presentation. This month, it's Ian Bernstein talking about the Misty 2 robot platform. So really looking forward to learning more about that. And then we'll just leave the chat open and the video open for people to sort of mill around virtually, ask questions, get help on their robot projects. And I think that's pretty much it. If I haven't missed anything important, is there anybody that has any robot related news that they want to share with the group?
Well, Chris, I can give a quick treasure update since we usually do that.
That's a great idea. So I'll hand it over to Dan to give a treasury update.
Okay, the update's very quick. We have, same as last month, we have 77 paid members, including family members. It's a total of 93. I'd love to see that number go up, although we don't need the money and you don't get a badge. So it's kind of arbitrary, but it is nice to see people joining and supporting the club in numbers. Otherwise, since last month, we've had one expense for $15 for Zoom Pro. That's it. Back to you, Chris.
All right, thank you, Dan. Any other robot-related news or club-related news? All right, I think we can dive right into the demo.
Yes, if I may, Chris.
Yeah. Yes, you may, Cam.
Next month is our HBRC 18th annual HBRC Challenge Phase 2. And as is the normal, I will be bugging everybody throughout the month of June to build your robots. I will entitle the posts 18th Annual HBRC Challenge Phase 2. So if you're not interested in hearing my blathering, just tune out, okay? But what we're going to do is what we did in May, and then the virtual meeting is going to be all show and tell. What we did in May was post pictures, videos, and stories about our robots throughout the month. And I'd like to use that material to, to feature the robots in the actual June meeting. So the June meeting is going to be all show and tell. If you're not actively building robots, what are you doing here? And so this is a builders club. Our trade and stock is functioning robots, partial credits given for works in progress. Also, I'd like to comment that we have like 120 members in our Homebrew Robotics Club Facebook group. So we're in Facebook and hitting on all cylinders there. There's a lot of interesting posts and things going on there. Next month is the 18th annual HBRC Challenge Phase 2. So I'll be bugging you all month long, and let's get some work done and build these homebrewed robots, because they're not going to build themselves yet. Unmute yourself, Chris.
Thank you very much. Thank you, Camp. Quick question for anybody that participated in the online virtual Maker Faire this year. That was recent. Any news from that, or did anybody present anything?
I presented something. We did a robot dance party, our group, the Cooper Tinkers. So that was pretty exciting. We have a video too, and I created a web page, I guess a little introductory post on beginners, how they can make robots at home. So that was fun.
Great. Do you have a video that you could share with us tonight?
Yeah, I do. So I just have to pull it up.
Great. Add your name to the list on You Have Something to Show, and
Okay.
we'll work you into the rotation. Thank you.
Okay.
Anybody else showed off at the Maker Faire? Okay. Let's just dive right into show and tell. And I think the first one to pipe up is back to Camp Peavy, everybody. So Camp, take it away if you're ready. And you seem to be muted.
Unmute
And you're
myself.
still
There we
muted.
go. There we go.
There you go.
All right, I've got a table bot to show. This is, let's get some video on here. This is Buggy, and I've done some work on Buggy. He's got an upper lower ultrasonics. The lower one senses the block, the higher one senses the box. This is a work in progress, so let's see how it goes. Well, I didn't quite get it there. It's not a contest, it's a challenge. All right, one more try.
Now, Camp, are you actually trying to sense the cube and move it, or are you doing the standard count?
He is it's got a sensor, the lower sensor. When it senses it, there it goes, and he should turn left here and try to put that block in. Let me try it one more time here. There it goes. So when it senses he's got the block, he turns and tries to sense the box with the upper ultrasonics. So when the lower, it's not staged at all. When the lower one senses it, he turns, and let's see if we can get it in the box. Oh well. Yeah, that's it. Thank you very much.
All right.
We're not proud.
So that's kind of cool. So you're just using two ultrasonic sensors, a low one to detect the object and the high one to detect the gate. All right. Let's see who's next on the list. Would be Ralph Hips, everybody. So Ralph, take it away. Arthur, I'm having trouble seeing the list of participants, so I can't pin the video. So I'm hoping you're able to.
Yeah,
or
I'm trying
hopefully
to keep
if Ralph
up. Yep.
speaks up, he'll take the stage.
See if I can switch my video feed real quick. Here we go. So this is a really quick one. I'm doing mostly a static show and tell today. I'm working on one of these humanoid bots, you know, with the bot kits. I've had this frame for some time, and I finally got all the servos for it, and I'm working on putting it together. So the idea eventually will be this is a humanoid, you know, about 15 inches tall. There's the rest of the frame. Work in progress. And the only other thing I wanted to show today was this thing. See if I can get it so you can see it okay. But this is a new gripper design I'm working on. I call that the Franken gripper because that's kind of what it looks like. And the idea here is it's a, you can kind of see where the black fingers end. This is an extension of the gripper fingers. I'm going to test this and try it and see if I can pick up larger rocks with it. And if this works out okay, I'll actually cover these metal extensions with some heat shrink tubing or some rubber stuff or something to make it look a little bit better. Anyway, that's basically it. And I'm going to have 3 of these. If this works out, I'm going to have 3 of these in my gripper with 3 separate servos, 1 for each pair, which will give my fingers the ability to close around something a little better than just the 1 servo I have now. And that's pretty much it for me.
Quick question: are you planning on having that claw on the end of an arm? Because that looks pretty heavy. And are you gonna have enough torque to move it around and lift it?
Yeah, that's the plan. Put it on the end of the arm, and it's not super light. I would agree with you there. And this particular servo is a real high torque metal gear servo, so it's a little heavier than the one I had before. I was planning on putting this one in the center and then two slightly lighter ones outside of it, but that will be part of the challenge. Will be lifting everything. The thing my arm seems to have plenty of though is torque. I seem to have torque for days. So right now, I'm not super concerned, but we'll see. We'll see. And,
is that the same servo that you're using for the elbow and the shoulder?
Not this, no. The elbow and shoulder and stuff are these 7-to-1 geared servo assemblies that I got from Servo City, and they have a ton of torque because they were a fairly powerful servo in them to begin with, and then you have this gearing assembly that gives it a 7-to-1 multiplier on the torque. You know, so it's a nifty contraption. Those things. So yeah, quite powerful.
So what,
All right,
what model, that's a humanoid, what model Robotis humanoid is that?
It's an older one. I've got it some time ago, and it's called the 17 Degree of Freedom, 17 DOF robotic kit. And this, I'm trying to think where the, I have a, this shows it here, I think, robotics kits.co. This one is from India, and this is the instructions that I finally found for this. When I first bought this this kit with all this stuff, I got it from some outfit in China, and it didn't come with any instructions really. It just came with some pictures, you know, to how to assemble it, which is a little hokey. But I finally found this from robokits.co.in. And so you might be able to get the skeleton from them. You can also get the frame from Amazon. I think they still sell them on Amazon. And then you'll need 16 or 17 of these servos. Amazon sells these MG996R servos. You can get 4 of them for $20. And we'll see how they hold up. Because this thing needs at least 16 servos, so yeah. That can be a significant expense.
You said $5 a piece? How many ounce inches of torque do those guys put out?
Oh,
that
not that much. They're sort of a standard servo in terms of torque. You know, nothing too crazy. You know, like a 422 or whatever it's called. Sort of a standard servo. Nothing exotic. They do have metal gears supposedly, which is nice. And they are definitely made in China. That's for sure. But it's it's a popular one, MG996R. There's a lot of different people that make them. Actually, they're fairly popular, but they're a low cost sort of Chinese servo, and like that. So I got a good deal on both the frame and the servos, and I thought, well, what the heck? I don't have enough projects, so I needed to get myself another one.
Oh, Ralph,
Yeah.
Just a comment, I have a Lynx Motion and it looks really similar, the same brackets and stuff. So I don't know if the instructions should be the same. I'll show it when my turn comes around.
Yeah, I think I saw yours a few months ago. You brought it in, and I think it's the same frame.
Did I? The black
I believe.
one? I don't think I've ever brought this one.
Oh, maybe it's not that. Maybe it's something else you brought then. Yeah. Okay. Yeah.
I'll show it on the.
Yeah, sounds good.
Okay.
Yeah, I just looked up the specs and it shows only 34 ounce inches. So I'll be curious to see if you can lift your arm up with that claw on it.
Yeah, well, so this thing is not going on this robot. So I don't know if that's, maybe I wasn't real clear on that. So this is for the other arm. Remember the really big arm I showed last time? It was lifting the rocks up.
Okay.
That's going on that, this thing. Yeah. This guy is not going to have that. No, the little guy, no.
Okay.
Yeah, sorry. Right.
All right.
ahead.
Thank you much.
Yeah.
Next up, we have Mike.
Mike.
I hope we only have one mic logged in.
Hey, how's it going? Thank you very much for the use of the word hokey. I really like that. That was cool, man. So the robot that I have to show for you guys today is this robot I've been working on for a while now. It has 3D LiDAR. It's got a Hukoyo. You know, I wasn't really planning on showing the robot, but I guess I could fire it up. And basically what this robot is, it's a differential drive robot with the 3D LiDAR system that I built myself. It has a lot of batteries on board, so it can run for a while. And it's quite big. It's as tall as my office desk. And the plan for this unit, I already have the ROS navigation stack implemented, but the problem is I only have it implemented on a 2D layer. So like when my LiDAR homes, it goes into that position. And I created a map using G mapping, and I'm able to navigate the static map using the local cost maps and stuff. And where I am at now, and localize using AMCL. Yeah, and where I'm at now is I'm trying to use the full 3D LiDAR data to create a spatiotemporal VXL layer. Sorry guys, I'm a little nervous. I've never been at a robot meeting before. I'm just kind of lone wolf here, so
No worries, you're doing great.
yeah, thanks, man. So that's what it is, and the plan is to put AR3 arms on it. I don't know if you guys are familiar with it, but there's a guy out there called Chris Annan, and he's awesome. He built an open source 6-axis robotic arm, and I've procured one of them. And the plan is to, once I finish the full 3D navigation with this thing, which I'm very, very close, is to put the 6-axis robotic arm on it, and to put a in-move type hand at the end of that arm. So that's my demo, I guess.
Very cool. Looks nice.
Hey, Mike, are you trying to use that voxel layer with the 3D LiDAR?
Yeah, exactly. That's exactly what I'm trying to do. And I'm trying to VNC into my Nook right now, but Ramina isn't cooperating with me right now. So I'd give you guys like a NavGoal demo, but it's not cooperating right now.
Are you on our mailing list?
Not yet. This actually, I got in touch with Chris just like 3 days ago when I was desperate to get this thing going.
Yeah.
And he recommended that I attend today. So I'm not on the mailing list yet. Join
the mailing list and start posting about this thing. We're also on Facebook too.
Okay, I'm not on Facebook. I'm not on social media. I'm more of like a call and get a beer kind of guy, you know?
Yeah, join our the HBRC mailing list. It's the links on the homepage.
Okay, will do, sir. Thank you very much.
All right, really cool. Thank you very much, Mike, sorry. Next up, we have George that's going to show something off. So take it away, George.
Okay, let me get unmuted. Okay, so I've been into building CNC controllers and CNCs from stuff I picked up at the electronics flea market. And let's see, let me get this clear here. And anyway, I have been using a thing called Bobcad that I got from a fellow, and it's pretty expensive software. Fortunately, I didn't have to pay anything for it to do my design work. And then I've been using Mach 3, and Mach 3 has a 500 line limit if you don't buy it. Well, I'm not into buying things like that. So I found out about a thing called Fusion 360, which is free for experimenters and people who aren't trying to make money. They can do some really heavy duty CNC type design work. Okay, so then I found out about a thing called Linux CNC, and it's free. And you can take almost any machine that has any kind of reasonable capability, and you download the Linux CNC disk or burn a DVD of it, put it on your computer, and it does commandeer the computer. So you want to start from scratch. Then you have yourself a dandy CNC setup. So what I did is I constructed, or first of all, I took the software, and would you believe I put it on a portable? This is a portable computer I happen to have lying around. And then I hooked it up to one of my older CNCs. This is kind of a prototype CNC, obviously. Fairly light duty servos here. A fairly heavy one on the y-axis, it turns out. But in any case, it took me about a week to sort through the code and the instructions and that kind of thing. But fundamentally, I have this now up and functioning. I'm having it's a kind of a chore to figure out how to set all the parameters just right. But let's see if we can get it to do something interesting here. I have a little program set up to basically draw a square. And you notice for my milling machine here, instead of a milling machine, I have a ballpoint pen. So I basically turned the CNC into a plotter, which is nice for debugging purposes. Okay, so I'm going to go to the, let's see if you can see this is the display unit, which is a bit different than if you're familiar with Mach 3, but if you're into CNCs, this is a very simple interface. And if all goes well, all I have to do is hit this button, and then away it goes. I actually wrote the G code directly, so it's kind of a screwball square it makes. In any case, if you're into building CNCs, you can come up with the each axis controller for about 30 bucks. I use 3N 35s to isolate the parallel port. This does use a parallel port. And I isolate the parallel port with the photo isolators. Anyway, it's been a really fun project. So I want to show you my current effort over here now, if you can see it. This is the next phase of this. Let's see if I can get in the picture so you can see where it is. Okay, I'm going to walk over there and point it out to you so you can see it. Okay, it's right here. That unit is another 3-axis controller, and all I have to do is unplug the portable, take it over and plug into the cable on that unit, and I have another smaller CNC. It's a 4-inch by 4-inch table that I can control with that. Anyway, I don't know if this qualifies anyway for the robot arm project, but it's kind of a pseudo robot arm. And by the way, it's a dandy device for making parts. I suspect it wouldn't be that big a chore to put a 3D printer to print parts with this. It's not that big a step to do that. In any case, if you like building CNCs, this is a fun project. Thank you.
All right, do you have any parts in particular that you need to make, or are you just having the fun building the tool?
Well, it's kind of funny. I have built some parts for like servo mounts. That claw I showed last month, I made that using a CNC. So it's good for making gears, small parts. The bigger table I have here, I can make parts about 8 inches by 14 inches. So I can make some reasonable sized parts. But I'm kind of a tool builder. I get a big kick out of building the tools. And sometimes I have trouble figuring out what do I want to make with it. Any case, this has been a fun project. Anybody has any questions, let me know, and we can fill you in. I regularly check my email every day, so if you want to start a thread or something, we can do that.
Yep, that happens a lot. We build robots and then we figure out what we're going to do with it later. Cool, thank you. So next up we have Chris Magri has a robot to show.
Hello. Can I share screen? Am I?
Yes, you can. There should be a share screen, big green button at the bottom.
Oh, it says host disabled participant screen sharing.
Arthur, I think you'll have to make her a co-host. Yeah, thank you.
So I'm showing mostly CAD. But... Okay, let's see. Share screen. Okay, I can share screen now. So my cameras are. This is the Lynx motion I was talking about. It's called the biped brat, but the brackets look really similar to what you were showing. It has, it's hard to see because it's all black, but these brackets in particular look the same as what you have. So, and then they do have a bigger one. I've never, so anyway, might check that out. Lynx motion, biped brat. Matthew Ibasu, he helped me fix my laser printer. So I'm able to laser print parts in plastic before I do them in metal. So this is a leg that I'm working on right now. It does actually, I can't actually actuate it, but I forgot about that. Let me show you the CAD because it makes more sense. Share screen. Screen one, screen two.
Were those rubber band tensioners? Could you show those again?
Whoops, sorry. Oh, I'm still. These are ball links from an RC car. It's a ball link and a turnbuckle. They use them for the steering. And I needed to make 2 parallel links. And after actually cutting out links and stuff, I just went, hey, why don't I just use these? Because then I can adjust the actual length of it. And that way I get some adjustability. And that way, if I don't drill particularly well or whatever, then I can adjust. That was my thinking anyway. Can you guys see my screen at all?
Yeah, we see your screen now. Thank you.
Okay, let's see. Oops, shoot, that's work. Don't look that. Okay, so this is, can you see this robot in CAD?
Yeah, that looks cool.
Yes.
So that's kind of what I was holding up. So these robots have, instead of having a knee joint right here, they have just 2 parallel links. So there's a motor here and a motor down here. And then as those 2 actuate, then the knee always just collapses up and then the foot will stay parallel automatically, so you can just pick the foot up and go. So you lose one motor, and I got this, Matthew found this on Thingiverse, I think, and it was just a bunch of little parts, so I actually put it together in CAD, so I'm pretty excited about that. It came out really good in CAD. Of course, I can't really build it like this. I need to make these into like sheet metal and then bend them and so on and so forth. So I'm kind of working on that now. And let's see. There's another picture. Here we go. Nope. Here we go. This robot here with the kind of the red eyes, that's the same robot. And this is from Robot Boxing League in Hong Kong, which is how we found this stuff. So I'm trying to make this one here on the right, and I'm pretty excited about it. Whoops, random pictures. This is kind of pictures of my CAD. And this is how originally I was going to do the links. I just cut out a piece of aluminum. And this got replaced by the ball linkage turnbuckle thing from their RC car. More CAD, more CAD. This is before I changed it. This is another picture of the same robot on the left. The robot's kind of getting clobbered by this big fancy one on the right. And this one on the right, it's the same robot, and he's just getting thrown by this robot. So that's kind of what I'm doing is, this is kind of a similar robot. The legs are the same. So I'm kind of going by these pictures and going by the CAD I have, and then trying to convert it to sheet metal that I can bend and actually make. So I'm kind of maybe 50% there on the leg, I'd say. I have 50% of a leg, but it's really fun. So, yep, that's what I got.
So how many servos per leg on this design?
So it's 2, no knee, and then 2 in the hip, so 4. Usually it's 2, 1, 2.
So what do you lose from that extra degree of freedom when you normally have a knee? So you said that the foot just has to stay parallel to the ground?
Yeah.
You're losing?
And then because there's one less servo, they're a little bit lighter, and they kind of actually hop, and they don't have any yaw on the hip. So they just kind of scissor the legs apart. I didn't have a video, and they just kind of skip sideways, and then they kind of bounce around a turn. If you look at some videos of Robo 1 or Robot Boxing League, I didn't prepare any, sorry. I forgot about this meeting.
Yeah,
so I don't really know what the leg thing gets you. I just kind of looked at this and went, oh, nobody's using the knee anymore, so I want to try that. So I think it unweights the robot so that you can skip around and be more dynamic. And then, but you can see they're doubling up on the robots in the top and the servos in the top. So I'm not sure what the whole linkage thing gets you. I think it's just easier to control. You basically just have this servo and this servo, and you move them opposite, and voila, you get knee bend. And you don't have to worry about the knee. And then to pick up the foot, I think it's just move them, and the foot's going to pick up and go over. I'm learning, so I don't have all the answers. It's kind of guessing right now. But I just kind of started looking at pictures, and I was like, oh, I want to make one of those. Yeah.
That is cool. I hope you do post progress on the news group, because I like that kneeless idea to save a servo.
Yeah, and they're all, let me see. Anyway, got a little lost on that. They're all like that these days. So I kind of was looking at these and see, this one has 2 links and another link. Sorry, it's so small. You can't really see, but this one has the same 2 links. They're all kind of, if you look at all these robots, they all have no knee, or that same 2 links. Sometimes people put 2 knees in the knee and then no servo there, no servo there. I think if your feet are lighter, you can move your feet faster, and then your robot can go faster. You can really see it on this red one. This red one looks pretty cool. So yeah, I'm just kind of learning, and here's some CAD I found. So yeah, thanks to Matthew for finding all this stuff on Facebook and he found the CAD. So we wanted to actually make 2 of these and then have a little demo. We wanted to have it done by now, but coronavirus, you know, so it's made it hard, but we're still plugging along individually. Yeah. Cool.
Is there any chance you have a VREP or a gazebo model so we can play with this in a simulator?
No, I just have, I could make it to whatever you need. I don't know.
Yeah.
I don't do
That.
I have CAD, but it's not actuated, I guess. Yeah, educate me. I don't really know what that means.
Okay, cool. Yeah, just post in the news group, and because I'd kind of like to help out if I could.
Okay, so do I post the SolidWorks file or some step file or what's useful? This is SolidWorks.
Yes.
Yes, post whatever I have. Okay, we'll do. Thank you.
All right, thank you very much. Let's see, let me reopen my chat window to see who's next. Shiloh, hey, how you doing?
Hey, I'm good. So my thing is, it's software only. It's this little tool I've been thinking of for years and years, and finally got around to making to convert a ROS map into a gazebo environment for you to use in simulation. I had this idea when I was interning at Fetch, and if you wanna know how long that's been, God, that's what, like 5 years. So yeah, so I finally did it, and I tested it on the little Fetch environment, and I have like a screenshot of the gazebo world, which I can show you. If I can share my screen.
So you say this imports RViz into Gazebo?
It imports the map. So if you have like a map server running, it just subscribes to the map topic and it produces this like environment basically just with a tall like rectangular prism on all of the like pixels that are occupied.
Do you have a GitHub for it or something?
I do not. It needs to be cleaned up a little more, but hopefully it will be on GitHub soon-ish.
Do you do anything to make it watertight, or is it just a bunch of rectangular prisms?
It's just a bunch of rectangular prisms. I've been trying to like simplify the mesh a little bit so it's like doesn't have like so many unnecessary triangles, and that's about as far as I've gotten.
Okay, that's still pretty cool and useful.
So can I ask you a quick question? That's super cool. So does that mean that you take like the 2D map, so something like this, and then you extrude the walls upwards?
Yeah, basically. So wherever there's like, okay, so actually I'm using OpenCV to compute just like the outer boundaries of all the obstacles. But then wherever there's like a pixel in that obstacle, I just extrude it up by like 2 meters.
Cool.
That's it.
Cool.
All right, thank you very much. Let's see, who is next? Wayne, did you have something to show? Oh, Damaris.
Dee.
I hope I pronounced your name correctly. And again, I don't see you on the list, so I can't spotlight you on the video. Are you ready to go?
I see her at the bottom, but she doesn't have audio associated with her account right now. I'm not sure if
She was talking earlier. Hello, Dee. Are you there? Unmute yourself.
Okay. Can you hear me now? Let me share my. Yes. There we go. Thank you. Okay, so this is what we did for Maker Faire. We basically ended up being a web page, and the theme of it was a robot dance party making at home. So they had explain why to take a break, family activity, and so why, and my daughter's challenges making the in move. And I posted a couple homebrew robotics club videos where we explained how we made some of the robots. But the real cool thing I'm excited about is one of our team members put together a compilation of our some of our group robots. So we have a robot dance party. It's about 3 minutes. So I'm not sure if you want to see all 3 minutes.
Sure, why not?
But it's fun.
Yeah, John and John's out there. They were asking about it. She saw that. Yeah.
Yeah, go ahead and play it if you're ready. I don't know if we lost her or not.
It looks like it's frozen. Yeah.
I see it spinning.
Yeah.
Yeah, she dropped off.
Okay, yeah, I think there's a bandwidth issue. That's okay. Hopefully she'll be back. Let's go on down the list. And, oh, I'm up next. So I'll share my screen. And we'll share that. Does everybody see that?
Affirmative.
Yeah, this is the post. There's sort of 2 small groups happening right now. It's the My First Robot and My Next Robot groups. And the My First Robot is just a really simple, it's called the Mott Bot, and it does the tabletop challenge, and it can do the maze challenge and line following. The second robot, we made some really good progress on. This is the news group where you can get information and then just pipe up. We would love to have people help us. We actually had the robot make it to Safeway, and unfortunately only halfway back we had battery problems. But the big issue was that we couldn't really drive it or steer it very straight. So once we can drive it better, I think that the battery won't be an issue. We do have a short little video that I will show, but Zoom is hiding my taskbar, so I cannot switch to it. Let me try Control or Alt Tab. So now, can you guys see the video?
Yes. Yep.
Yes.
Okay. So let me just hit play on this. And this is just a quick compilation of videos.
To make his first journey to Safeway. Pilot John Erickson.
Are you hearing the audio?
Yes.
Yes. Controls are a little wonky in standard WASD, but we're headed out to Safeway.
So we started from my house in Belmont.
To the front door. Software to make this a little easier.
This is right now being controlled through VNC connection. Shortly, we're going to have this also controlled through Remo.tv.
Coming down the street, if you don't want to worry about hitting cars on a sidewalk, I need more room.
Yeah, we didn't want to hit any cars, so we chose the street rather than the sidewalk.
Hey, navigated the bumps pretty well.
And I spoke too soon.
And we've successfully made it to the Safeway parking lot.
So we did make it to Safeway, still having a little bit of issues trying to steer it properly. And so now we're in Safeway. It doesn't have an arm yet, so we had to buy the groceries ourselves and put it in the box.
We're just testing a robot. We're hoping to honestly do grocery shopping.
It did get a lot of attention. We had to carry it out the front door because we were blocking other people.
Groceries. It's a little bit difficult to drive. We need wheel encoders to make it easier. We need standard tabletop technology to keep from going off the edge of the sidewalk. Ping sensors to keep it from running into other walls on the sides. And yeah, and power switches. We've had to reset a couple of times. So 2 power switches, one for batteries, one for Raspberry Pi. Also, the Raspberry Pi power, you have to take a shortcut through the, either way, or sidewalk's fine. And have the Raspberry Pi auto boot up to the Robot One software.
All right. Well, that was 2 Sundays ago. That's John Carlini, John Erickson, and myself. And Steve OK helped us put that little video together. So thanks, everybody. We really would love to get some help. So if you want to have a robot that will go to Safeway and do your shopping for you and bring it back, you're welcome to join this little group. That's pretty much it. Thanks. Any
Where
questions?
do you put the mask?
Hopefully it won't need a mask. But you can see we were wearing masks as we were babysitting at the Safeway and back. All right, let's see who's up next. Rohan.
Hey, Arthur, I'll need screen sharing in a moment. So basically, a lot of us use these Raspberry Pi cameras. This is the standard Raspberry Pi camera V2. For computer vision things, we use them with ROS, and most people end up using Raspicam node, which is one of the maintainers for that. That's a ROS node that lets you connect the Raspberry Pi camera to ROS. So recently, they released the new Pi camera. This one has much larger, it has interchangeable lenses, significantly better light gathering, and it's just an overall better camera. So if you want to do computer vision tasks that require better camera data, this allows you to do that. And it is now working with the Raspicam node. So with the development version of the Misty Robotics image, you can load this up. And let's see, share. I'm going to try and share my screen here. Okay, can you guys see that?
Yes.
Yep.
Okay.
Yep.
The Wi-Fi here in my garage is not great, so it's a bit laggy, but this is ROS running on the Raspberry Pi. and showing the video feed using RQT image view onto my laptop. This is the wide angle lens, so that's why it has a bit of a fisheye effect. And I'm planning on experimenting with a couple different lenses because you can put third-party lenses on this thing, and seeing how well it performs. But just wanted to say that for people who use Rastercam Node and want better cameras, the Raspberry Pi high-quality camera now works. That's it.
All right, thank you very much. Dee Dee, looks like you're back on. Are you able to try again to share your video?
Well, I'm afraid the same issue is going to happen. And so I, with this stinky computer, but I did already share the link on the page there. So the video should be accessible over there.
Okay, by page there, do you mean in the chat here in Zoom or on the news group for HBRC?
On the news group.
All right, thank you. So everybody can click on that and see the cool
quick
video.
question. Someone asked on the news group what tool you use to mix that video with. I was kind of curious too. I love the effects. They were nice.
I have to look. I think it's something called Quick. It starts with a Q. I think I answered camps. Yeah, one of the ladies in our group actually mixed the video with it. And so she said that it did most of the work automatically. And then she just used open source music for the music.
Yeah, there's a response on the mailing list.
Yeah, it starts with a Q, like Quick or something.
All right, well, thank you very much. I think that's it for the robots. Is there anyone else who can speak up now or forever hold your robot?
Are you guys interested in the demo of navigation?
Sure.
Yes. Mike again.
Yeah, because I didn't want to waste time. So what I'm going to do now is I'm just going to launch the... Oh, sorry.
Hey, Mike, if you could unmute yourself, thanks.
Yeah, sorry, man. I just realized that.
No, that was my fault. I accidentally muted you. Sorry about that.
Yeah, no worries. So right now the robot's powered up, ready. The light are home. It's localized on the map, and now I'm gonna give it a 2D nav goal to go into my kitchen where my wife may be. So good luck.
So is that Arviz?
My wife really doesn't like it when that happens, so I had to pull the plug on this one. The last 3 runs were successful. She doesn't like it when the walls get banged up. It's a problem with robotics.
Is that Arviz? Is that Arviz you're using, Mike?
Yeah, so what I have here is I have Arviz showing the static cost map, the global cost map, and the local cost map. And yeah, because I killed my PC, that's right. So yeah, that's Arviz, and I also have the whole project done on Gazebo, which is why I was so excited about Shiloh's project, because I have a 2D map of my apartment, and if I could extrude it upwards and make it into a 3D map and navigate my robot there in the Gazebo environment, that'd be awesome.
Very cool.
Didn't complete the
All right, very cool.
Yes, for now, I guess.
Nice to see somebody other than Camp showing that off for a change.
We've all been there, Mike.
All right. Next, Brian Higgins, did you have something to show?
I know you meant that with affection, Chris.
Of course.
I'll give you my machine learning demo.
Wayne,
Okay, I guess Brian isn't here. If there's no more robots, I think we don't really need to take a break because we're all at home and can go take a break whenever we want. So I think, Ian, if you are ready, we can, if there's nobody else piping up, we can start into the main presentation. So I'll give a few seconds for anybody else to pipe up. Otherwise, Ian, if you're ready to go.
Is that a dog howling?
No, it's at the 8 o'clock COVID howlers. I have a neighborhood where people love to howl.
All right.
Certain neighborhoods are worse than others, from what I hear throughout the world.
It's a thing, huh?
It's a thing, and I will mute my microphone so that we can listen to our presentation in peace.
You guys ready?
Yeah, welcome, Ian.
Thanks for having me. This is really cool. I'm out in Boulder, Colorado, and I've been trying to make a meeting for years now. And whenever I'm out in the Bay, just for whatever reason, it's never lined up. So it's cool that I'm able to participate finally, and it's so cool to see all the projects you guys are working on, and it's cool to see your labs that you guys are in. It's pretty awesome. So yeah, I'm Ian Bernstein. Just a little bit of background on me. This is Misty. I got into robotics when I was 12 years old. If some of you guys know a type of robots called beam robotics, that was what I started with, like way back. That was probably almost 25 years ago. Building these little solar powered beam robots, a lot of biologically inspired robots, so legged robots. A lot of them were analog based versus digital. It was invented by this guy, Mark Tilden, who worked at Los Alamos National Laboratory and went on to build a bunch of toys, so like Robo Sapien and a bunch of other stuff. But yeah, I would just basically sit, I homeschooled, so I'd sit at my desk taking apart TVs and VCRs and cassette players and pulling out motors and stuff, and because I didn't have any money, and building these robots. I built a website, Beam Online. It was teaching other people in the community how to build these beam robots, and went on to study electrical engineering, computer science. Never graduated, but started working part-time at a robotics company building sensor packs for humanoids. I was kind of looking for, what I was going to do after college, and went to like a career fair, and all the jobs just sounded really boring. So I ended up dropping out of school and starting my own company, which is a web design company, to learn about business. I did that for 4 years, and then really wanted to get back into hardware and building robots more. It was end of 2009, and I was working at this robotics company on these humanoid robots, and was playing with the original iPhone, and had this idea, like, why can't we use the phone to control the robots, right? Because this thing had way better screens and internet connectivity and sensors and everything than the microcontrollers that you could buy at the time. So we started prototyping, controlling robots with the smartphone, and quickly realized that nobody was controlling not just robots, but anything with the smartphone at that time. And started playing around controlling my garage door with the phone. I put a remote starter in my car and could start the car and roll down the windows and stuff from the phone. With this idea, more of a platform idea, got into a program called Techstars, which is a seed incubator in the summer of 2010. We were almost out in Y Combinator in the Bay there. We ended up being the first hardware company to go through the program. But anyways, like when we got in, it was like, well, what are we going to control? Like we can control anything with the smartphone. And we ended up coming back to robots and coming up with this crazy idea of a robot ball, which we called Sphero. We ended up raising some money and turning Sphero into a product that you can still buy today. It's mostly used in the education space in tens of thousands of schools around the world. That later went on to working with Disney, where we got connected with the CEO of Disney, and he showed us a picture a year and a half before episode 7 came out, BB-8, and he knew that we had made Sphero, and we're like, hey, if you guys can make Sphero, can you actually make a real BB-8? Because at the time, everything was puppeteered for the movie. So we ended up prototyping one that night. When we were out in LA working with Disney, like we had my co-founder Adam and I, like we had all of our 3D printers and molding supplies and paint and we're the crazy people there with just like stacks of equipment. But we 3D printed a head and put on some Star Wars music, and we had magnets and stuff, and ended up making the first BB-8, which took about a year to get to market. And we sold millions of those. But it was when we were out at Disney, we're actually at the Golden Road Brewery down the street from Disney's creative campus that we're working out of in 2014. And we're thinking of like, how could we get more robots into people's homes and offices doing useful things beyond just vacuuming and beyond just toys and entertainment. And of course, the education side is really awesome, but can we do useful stuff for people? And we thought, well, why can't we make a real R2-D2 or a real BB-8? And that started as just a product team within Sphero. We prototyped a lot of stuff. Again, thinking about these more advanced robots. And eventually it turned into a platform, because at the beginning it was like, well, if we're going to build this robot, like what is it going to do? What is that killer application that we're going to launch with this robot? And it always broke down, because it would either be too expensive, or the technology wasn't good enough at the time, or just the market wasn't big enough. So eventually we sort of thought back to like how the computer industry started. And I'm sure some of you guys know how it started a lot better than me, because I was only like, I was like 5 when I got my Apple II. But I think it really started with a lot like people building the software, because at the beginning it was like the homebrew computer clubs, right? And people building computers and trying out different ways of building the computers. And it got to a certain point where like maybe with the Apple I or the early Apple IIs that you sort of had somewhat of a stable platform where software developers could then build on top of it and really progress the software. And that really is what made computers take off. So the thought was like, could we do something similar with robots? Could we create a stable enough platform, a capable enough platform with robots that then software developers could come along and start building applications and skills for these robots and progress robotics to get more of these robots out into the world. So that's what we started about 4.5 years ago. Again, it was about 2 years within Sphero, 1.5 years within Sphero, and then 3 years ago spun it out into a new company called Misty Robotics. You guys were showing and telling, I was thinking, as you guys were doing that, that I had one of like the early prototypes that were looking at like different form factors and stuff. So this was like a little track platform that I think we just got off like eBay, and then 3D printed different mounts. There's some time of flight sensors in here. There's a couple ultrasonics. I have a standard webcam, and I think for this one we're just using, I think this one used a Dragon board that we got from Arrow as the processor, and just like a Microsoft webcam. And then there's a couple servos. So we're thinking like we learned a lot about personality from Disney and our work with Sphero and BB-8. So like the eyebrows can move. So it'd be like, you know, curious or angry. So we were thinking about like different form factors, and eventually through, you know, hundreds of iterations on the product side, came up with this form factor for Misty. September of last year, we started actually shipping the product. And that is Misty that you see here. So the actual robot, I can kind of run through some of the functionality. So there's capacitive touch. She'll respond to different things. This is our capabilities demo skill. So it just shows off a lot of the functionality. All this stuff is on GitHub. Visor, so high-res camera for computer vision. You can put, you know, your TensorFlow models, or if you want to train models, you can put those in. The other three cameras and the laser projector is the occipital structure core sensor for mapping and navigation. And Occipital has an office, their main office just down the road from us here in Boulder. So we work with them on the SLAM side. Of course, the screen, there's like, there's an indicator LED that we turn on when she's recording or doing audio recognition. Flashlight, there's 3 degrees of freedom in the neck, so you get the tilt so she can get curious. The arms are 1 degree of freedom and can move around. Speaker system, we spent a lot of time on the audio box design to get really good sound. And then on her base, there's 3 time-of-flight sensors in the front for object recognition, 4 on the bottom for edge detection, and then 1 in the back for backup. Treads, and then we do wireless charging. So both wireless charging, there's a little charging mat that you can drive on, and also a DC jack under there if you want to plug her in. And then of course, I'm a hardware person, robot person, so we wanted to make it really hackable from both the software side. So lots of APIs that you can get to pretty much everything, low-level access to all the sensors, RESTful API, you can load skills on Misty and JavaScript that are autonomous or C#. And then hardware size, we got like this panel up here. A bunch of these panels are magnetic, so it's not like a real antenna that pops off. You can 3D print your own accessories, so we put like thermal cameras on there. One of our engineers is into like LED artwork, so he made a LED mohawk for Misty, so you can dress her up. There's a trailer hitch on the back that pops off. So you can tow a trailer around. We have the backpack. So this is our Arduino version of the backpack. This is the standard one. It's just magnetic, so it pops on and off. The stock one basically just has a proto board in it. But of course, the Arduino one is just a standard Arduino. It looks like an Arduino Pro Mini with serial and USB ports. On the back, there's just little pogo pins that you can hook on. So that's what people use if you want to hook into your own sensors, or we had some students at a university build a 3D printed arm for Misty. So they had servos, actuated servos, so she could actually reach out and grab stuff, and all that's controlled from the backpack. Of course, we have like all the 3D models and everything for Misty on our site, so you can 3D print your own attachments for designs. So what customers are using Misty for right now? So we have basically, so there's a lot of different stuff like students in education, teachers using Misty to teach programming. again, because you can do a lot more real stuff than you could with maybe just a Sphero or some of the Lego Mindstorms or some of the other kits out there. You can do a lot more sophisticated stuff, especially things like CV. For other use cases, we've seen two areas. So one is children's therapy. We've had a lot of organizations and therapists starting to use Misty. Of course, a lot of that stuff shut down with COVID. So there's like an organization on the East Coast, Fine Arts Miracles, that has a bunch of therapists that were going into homes with kids and schools, teaching kids with learning disabilities, teaching a lot of social skills with Misty. But of course, that's sort of on pause. That was in pilot right when COVID hit. And then the other area is a lot around elder care. So thinking about using Misty and skills for companionship, but also for safety. So doing fall detection, using computer vision, 3 microphones. So whenever I say her name, that's why she's like beeping. She's looking for that wake word. You can do audio localization with the microphones on the top. So if somebody made a screamed or yelled for help, like Misty could localize on that sound and drive to make sure they're okay, and use voice recognition to say, hey, are you okay? Like, do you need help? Yes or no? So you could do things like that. We had a customer just maybe a week and a half ago that posted a video of doing face mask detection. So he was doing that with, it was basically a face mask reminder for a business. So if you didn't have your mask on, he had Misty say, your mask isn't on. Could you please put it on before you come in our, business? Lots of different things and a lot of creativity. We're sort of in that validation stage right now where people, unfortunately, were going into pilots. One of the elder care pilots was in Barcelona. We had the company on the East Coast, and we had a handful of other customers getting ready to go into pilots right when COVID hit. So we're sort of waiting for a lot of that to sort of die down and for them to come back. And on our side, we're developing out a lot more of the APIs for Misty, always improving documentation, putting out more sample code, putting more capabilities into Misty on the software side. There's a lot of hardware here that we haven't fully taken advantage of. And then because we're all in lockdown, we've been working on some health screening applications. So just like the last few days, I've 3D printed another visor for Misty that sticks out a little bit with some slots for a thermal pile sensor, an IR-based temperature sensor, so she can read your temperature with the time of flight to make sure you're the right distance away, because a lot of people don't use those temperature guns correctly. You really need to be 1 or 2 inches away from somebody, and most people don't do that. Like when I went and got my haircut last week, the girl just like walks up and she points the temperature gun at my head like 1.5 feet away. There's no way that reading is anywhere accurate. So doing some validation things like that. What else? Yeah, I'd love to make this sort of interactive too, so I can go off on all kinds of tangents and challenges, engineering challenges, more things that people are doing with Misty. I can show off some more of her capabilities. Let's see if she's. See what happens.
A screenshot of a computer.
So that when I hit the bumper, basically it snaps a picture, it sends it to Microsoft Cognitive Services that does some computer vision. It basically gives you 1 sentence of what it thinks the context of that image is. And then it gets sent back down, and we send that sentence to Amazon Poly. To do text to speech, we get the sound file back down of her speaking the sentence, and then she speaks it out. Let's see if she can do something a little more interesting.
A man standing in front of a television.
Pretty much, it's my monitor. We can do things like, you guys could try this. We'll see how this goes. So this phone number, it's probably backwards, but I can read it. I'll put it in the chat maybe. So this is the phone number for Misty using Twilio. If you text this phone number, here, I'll just put it in the chat real quick. If you text,
It was correct, the
okay.
backwards.
I'll just put it in there anyway, so I have to hold it up. So you can text different things to her. You can say like change the LED color and she'll change her chest LED. You can say take a picture and she'll snap a picture and MMS message it back to you. You can say, you can put her on the floor in a bit. You can say like drive forward 20. She'll drive forward 20 centimeters. You guys seem like a somewhat safe group. You can also say speak. She speaks different things, whatever you type in. So you can interact with her that way. And of course, as a software developer, you can hook up to all the APIs on the internet. That just makes her a lot more powerful in the things that you can do, not just the hardware that's built in. So Wayne said, can you show some of the software? Yes. So let me see if I can do a quick screen share.
Speak, thanks for visiting Homebrew Robotics.
Awesome.
HBRC rules.
Yep. So on my screen, this is just a website that you go to, sdk.mistyrobotics.com. You can put in her IP address, which you get through an app. So you just load the app, it's all Bluetooth. It just gives you, you can select your Wi-Fi network. So we wanted to make that process really easy. And then it gives you her IP on your Wi-Fi network.
Hi, HBRC.
There's different tabs, so Command Center. You can basically get to all the functionality of Misty. So
speak, I need a laser on my head.
You can play different sounds. You can change your eye images. You can upload different images. You can upload different sound files, MP3s, WAV files for things she can speak. You can drive, move around. You can see and generate a slam
Let
map.
the man speak. Stop texting me.
I could also turn her volume down. You can see the audio localization, you can take photos, see all the raw sensor data out of the time of flights. When you're building your skill, we have JavaScript in here right now, but you can go to like, say, expression, change LED. So we'll change her LED, it's blue right now. We can change it to green. And she just changed it to green. I'm gonna change it back to blue because it's part of the skill when she saw my face, but you can see what the code is. You could just copy and paste right into your JavaScript program. Again, just to make it like really easy to build your actual program. I think it's sharing this whole monitor so you can see just what a skill looks like. There's two files. There's a JSON file that you specify things just like the name of the skill and some global parameters. And then the skill itself is just a JavaScript file. So if you know JavaScript, this is super easy to code for. This is a skill I made that pulls weather data from a weather API. And then when I hit our bump sensor, it will check the weather from my zip code. And then depending on what the weather is, it'll play basically one of 20 eyes that I created in Photoshop. So if it's like raining outside, she'll get like little rainy eyes. Or if it's sunny in daytime, she'll get sunny eyes.
Hello, this is a test.
So this is a test. It worked. And then once you have your skill, you can either use Visual Studio Code, and we have a keyboard shortcut that'll push the code right onto Misty to run, because we know when you're debugging, you just need to do that a lot. So we built that right into a Visual Studio Code plugin. Or you can just take your 2 files and you go to the skill runner over here and just select them and just drag them into this little box right here. And that'll upload your skill. And this will manage all your skills. So your skill would show up here, weather eyes on there, running the capabilities demo, and this lets you start and stop different skills. And skills can run concurrently. So you can have, and sometimes you have to be careful because they can conflict with each other, but you could have a bunch of different skills running on her at once. Like I could probably, I don't know what'll happen. I could try to start the weather eyes. See what happens. Yeah, so she just checked the weather. Now you guys can't see her because I have my screen shared, but she has little clouds on her eyes. What else? Let me do it again. Yeah, it's hard to see with the glare. Yeah, her little cloudy nighttime eyes. Yeah, what else are you guys interested in? We got lots of stuff.
Now is the time for all builders to come to the aid of their robots.
Say, can it find its charge base autonomously?
Yeah, we're still tweaking it, but yes. So we use yeah, I'll just grab it. I'll show you what it looks like. So this is the charging pad, and because she has an infrared laser projector and the infrared cameras that we use for the occipital slam system, we did 2 different methods for finding the charger. So one is these 4 dots on the front and the 2 dots on the top are a super highly IR reflective material. So when her projector's on, those cameras, these just light up with the right contrast. It's just super bright white dots. So we use that if it's like a dim environment. And then when it's lighter, we just use the logo as a fiducial to find the charger. Wayne asked in the chat on price. So somebody asked, Wayne asked what the price is. So right now we have 3 different versions of Misty. So we have a basic version that doesn't have the slam because we found that a lot of applications are basically you don't need her to drive around. It's like she's a greeter or like the temperature checking that I mentioned earlier. She's just sitting static for the most part other than moving her neck and her arms. So they don't need slam. So the basic edition is 2,000. And then, let me get these all wrong. The standard edition, which is this one, which has all the slam stuff in it, and the wireless charging, I think it's 28, 2,900. And then there's 3,300 is the enhanced edition, which basically has a SOM. So there's 2 SOMs in her head. Both Qualcomm Snapdragon processors. One is used for basically running all the skills, running the main home robot app. That one is a Qualcomm Snapdragon 410. And then we have a Qualcomm Snapdragon 820 that's a lot more powerful. We'll use that one for CV and SLAM. But in the enhanced version, we have a version of that SOM with a lot more memory, so she can map a larger area. Although we've done experiments too with SLAM where, although sometimes she starts running into memory constraints with a certain size map, you can stitch those maps together relatively easily. So you can map several rooms, and then when she drives into the new area, she just just loads the new map into memory and goes into that. So which 3D camera are you using? What kind of range, field of view does it get? So the actual sensor is a sensor from a company called Occipital. And if you look at Occipital, it's the structure core sensor. Field of view, I don't remember the spec off the top of my head, but if you go to their website, it should just be on there. The range, of course, with these types of sensors, you lose a little bit of range on short distance. So I think it's about 3/4, it's about half a meter to a meter. Somewhere in there is the minimum range that you get before it just gets washed out. And then as far as long range, I'm thinking 3 meters. But again, it's probably on their site. I'm just not remembering off the top of my head. Can you talk about Microsoft Azure integration with Misty? Are there any plans for AWS? Definitely. I think the only reason we used Microsoft initially was, I don't know. Actually, we'd gotten connected with some people at Microsoft pretty early on in the project, and we went up to Redmond a couple times, and one of the Snapdragon processors on here were actually running their Windows 10 IoT core because they had really good development tools. But that's probably why. But we're super agnostic. Like, there's actually nothing from the cloud side running on Misty by default. So all of those different services, they're just part of the skills that we're writing. So we definitely do have some example code, like in the demo where she speaks out what she sees from Microsoft. We're using Amazon Poly to do the text to speech. We've done stuff with IBM Watson. We've done stuff with played around with Google Assistant. So it's really up to you guys as the developers to pick whatever service you want. We're completely agnostic from the robot side. So yeah, it kind of answered part of the question of what OS are you using. So on the 2 SOMs, we're running Android on the 820, and we're running Windows 10 IoT Core on the 410. But kind of depends, like for the most part, you wouldn't even really know what operating system is running underneath if you're just writing your skill in JavaScript, or I guess on the C# skill side, you would tie into Windows a little bit more. And you do have a lot more low-level access on that side. But otherwise, you don't really care too much about what the actual operating system is. What capabilities would we like to add next? Some of it is just like our experimentation with using Misty as like a health screener. So we're adding capabilities like the visor with other sensors like thermopiles and temperature IR cameras that we're experimenting with different sensors that hook into our visor. Of course, all these sensors, I don't have this one wired up yet. I gave the one that I wired up to one of our engineers, but that all goes back to the Arduino backpack. We can then hook all that data into the robot, into the skill. We're definitely working on making a lot of the stuff more robust. So voice, her wake word, the SLAM system, making that more robust. Personality, yeah, we're definitely working on the personality of Misty. So like some of the stuff, like her blinking, like that is built into Misty, into the core of the robot. You can turn it off if you want as part of your skill. But we have a whole pack of like eyes that we've created. So probably 70 eyes and 70 different sounds that we provide. So if you want to build personality into your skill, like you have access to eyes for fear and happy and sad and all those different emotions. And then we have sounds that you can associate with those different emotions as well to make it easy to build personality in.
Say, hey, what's wrong with my personality?
Say, hey, what's wrong with my personality? Can you move around? Does she have an explore mode? So explore mode, like not built in. But we definitely have a lot of explore skills. So in our GitHub repos, we have definitely some explore skills that use the time of flight sensors to wander around that you can build off of really easily. And can we see her drive around? Fortunately, my camera is like on my monitor, which is somewhat like hooked into my desk. So, I would just basically just say go to like our website or our YouTube channel. If you just search for like YouTube Misty Robotics, or I can put her on the ground if you guys want to like text and just like drive her around while we're chatting. And you could probably, I don't think I have it hooked up, but it's pretty easy to hook her up to like a Twitch stream, so you can actually get a live video over the internet. You should be able to just text like take a picture and get a picture back, and then you can say like drive forward 20 or probably more, like drive forward 100, and drive her around. I guess I could put her like back here. I think you can text like different personalities too. Say like Misty, get happy. Word 50. Might have disabled it. Never mind. Might be disabled. Maybe I can drive her on command center. There you go. Yeah. Where can we get the cool t-shirts? Right now, sometimes we give them out at like different events and stuff. Hopefully we'll be able to do more events soon. But yeah, usually we've been out in the Bay like a fair amount, like doing and all over, doing some more like live events with Misty where we have shirts. And I don't even know if we have any of these left. But yeah, hopefully at some point, like if you guys are interested, maybe we can send over some swag to you guys. So good question. So good question. Like if, sounds like we're developing our own framework. Did we consider using ROS? Yes, we definitely considered it. And yes, we are sort of building a lot of our own framework. Part of it was, I think ROS has gotten better recently, more secure, better functionality. But I mean, when we started the project 4 years ago, it was still pretty academic. And we did want to make sure that this robot, I'll get into like security and privacy and stuff, but we wanted to make sure that it could go into like an elder care facility or someplace with kids. And at the time, ROS would have taken a lot of extra work, which companies have, to make it secure. So basically we decided just to go more of the ROS wrapper route. So we've had some customers already start to use the RESTful APIs and write ROS wrappers. So if you're in the ROS world, you can run your ROS code on your computer and interface with Misty that way. On security and privacy, we we consciously decided to make Misty actually less private and less secure at launch, to give people more freedom to be able to play around with the functionality without being sandboxed too much. And once we sort of figured out what people wanted to do, then we could start to close things off and sandbox things as appropriate. So we are still like pretty insecure and pretty not very private. Again, that was a conscious decision on our side to give more freedom to developers, at least initially. But as we are starting to go into some pilots with some customers, we are starting to lock stuff down. Is Misty self-contained or needs your cloud server to work? Also, good question. So we have no cloud server functionality of our own. So yeah, the robot is 100% self-contained. Everything runs on the edge. We do some things on the edge, like face detection, face recognition, that's running on the robot. Of course, the SLAM and stuff is running on the robot. Anything cloud-based, that's 100% up to the developer in their actual skill, what they want to use. So again, if you want to use like Microsoft or Amazon or IBM, Watson, or whatever services you want, that's totally up to the developer. And we try to provide just a lot of sample code to make it easy. So for as much of those different services as we can to give you guys starting points. Any other questions?
So you're going to raffle one away this evening, right?
No. But,
definitely heard something about a raffle.
We should definitely do something in the future though. And I'd love to, when stuff starts opening up, definitely make it to like an in-person meeting. Would be awesome. And maybe we could do something like that, or yeah, definitely bring a bunch of shirts and, you know, other fun stuff. Let's see. What do you think?
I remember when you guys were at Maker Faire.
Bay Area?
Yeah, 2018, good times.
Yep. Yeah, that was a fun one. I think that was my first Bay Area Maker Faire. I'd been to ones in Colorado, had been to the New York one, but that was awesome. It's huge. Somebody asked, what do you think sets Misty apart from all the other robots for kids? Everybody seems to be making a robot for kids, which is totally true. There's so many now. Yeah, you go to like some of the education conferences like ISTE or even things, you know, CES, and you walk around, there's like 400 robots for kids. Where Misty sets apart, I would say, so two things. One, it's more high school and college that are generally using Misty. So it's a good, it's a good next step beyond a lot of the stuff that's out there. So robots like Sphero and BB-8 that teachers are using to teach sort of block-based programming, and then they might do some stuff in JavaScript. Here's the Sphero rover. Misty is sort of the next step. So again, like high school kids or college are using it for more sophisticated stuff. And then I would say the other piece is not all of them, but I would say most of them, I would say they're kind of dumbed down a little bit. Like the robots out there. And I don't know, I'm sort of a believer in giving kids like the real tools, like why not play around with like SolidWorks and writing, you know, using the real tools that we use as engineers. So So I think Misty has those sort of more sophisticated functionality. There is ways to sort of simplify them to make them, you know, some of the concepts easier for kids to sort of get into, but they can grow into like, and using a real robot and real programming languages that we would use and real tools that we would use. So I think that's another advantage of Misty as well. It's not like a, you know, some tinker thing or, you know, some of the other stuff, which is awesome. It's getting a lot of kids into STEM and STEAM, but I think there's an advantage, you know, especially of starting with that stuff and then moving to something like Misty where they can quickly do real things. Let's see, Chris had a question on gears, types of motors in the base. Let's see, types of motors, gears. So we're using just regular DC motors. We have VRs, variable resistors in all the joints. Gear boxes are a combination of plastic and metal. So we did a lot of life testing on those, and you'll see they're all clutched. Like, unfortunately, sometimes you drive your Misty by accident off the table, and with all the production ones, we've never broken anything. But yeah, I mean, you can crank her around and all the clutch is engaged, but it's not actually hurting the robot at all. Just to make her really strong. And then let's see, there was another good question. You know, given uphill battle with social robots, Kurijibo, Cosmo, has Misty Robotics been able to succeed where others haven't? You know, I hope we do. You know, we just started shipping again in September, so they haven't been around for that long in the market, but we are seeing some real traction. I mean, our differentiation has really been around our developer focus versus trying to come up with sort of the killer use case ourselves. So unfortunately, Curry sort of never got to that stage just because of where they were with Mayfield and Bosch. That was really unfortunate that they got shut down. I know on the Jibo side, like, it's also a great product. They did a lot of great work on the personality side. And I know they were switching to more of a developer focus and realizing that was a really good path to go down, and then just ran out of money. Also really unfortunate. You know, Cosmo on that side, coming from my experiences with Sphero, toys are also just, it's a really tough space, very price competitive. It's hard to get a lot of technology in a cheap device. But all those companies have done very good things. Like all of them, friends with a lot of the founders. Again, our sort of differentiation is on the very developer focused and business focused for Misty as a platform versus us trying to figure out what that application is and build it ourselves. You guys have good questions.
All right, well, thank you very much, Ian. Are there any other questions? I don't see any in the chat. Definitely a big round of applause. Thank you.
Yeah, thanks.
You sure?
All right. So, yes, we'll leave the chat open for a little while.
He said something about a raffle.
Camp really wants one.
Really want one.
Yeah, maybe we can figure something out.
Yeah.
Nancy wants one too. Chase the cats around.
All right. Well, I hope to see everybody at next month's virtual meeting. I guess Arthur willing, we'll leave this Zoom open for a while so people can talk, chat, and ask each other questions.
Chris, can I interject, please? June is the challenge month, so everybody needs to be building for the June 24th meeting. The whole meeting is going to be show and tell. And I want a lot of posting of pictures, videos, and stories about the robots that you're working on. Everybody's on the mailing list, yes? Okay, good. Thank you.
How do you get on the mailing list? Sorry, guys.
Go to our HBR, go to the Homebrew Robotics Club homepage. It's hprobotics.org, and there's a link there to join the mailing list. It's a Google group.
Ah, okay, cool. Thanks. Ian, cool robot, man. Thanks.
Yeah, you're welcome. Thanks for letting me present.
Mike, there's a link to the homepage.
I found it. Thank you, sir.
Thank you, Ian. That was awesome.
Hey, you're welcome. It's cool to be around you guys. I'm gonna be firing up my soldering iron here in a minute and
every month
finishing the visor.
Last Wednesday of the month.
Cool. Yeah, I'm definitely gonna join the next one.
We have a
so I have a Remo.tv robot that I can show next month. So it doesn't sort of fit in the standard categories, but you know, at least people can drive around and see my house.
That'd be cool.
It's also kind of fun to see everybody's basement and garage and work area. You can kind of see all of my junk in the basement here.
Well, this gives me a motivation to replace a battery eliminator circuit. So I've been building Small Cat, which is a quadruped based on a Worcester Polytechnic design. And I replaced the head. Now it's a little, I don't know, more appropriate for Halloween. It's a little Terminator-ish looking now rather than furry friendly. But that's been a lot of fun. It actually uses Bowler Studio, you know, yet another robotics development environment. So it's in pieces right at the moment. So I'll have it put back together and have it do some tricks.
Okay, I'll just inject here that the following month after the June show and tell will be Brian Higgins showing his the cane he's been working on literally for over a decade. Okay, so he's been a member of the club for even longer than that. So I just thought I'd put in a little plug for Brian Higgins, who had to leave early tonight. He was going to give a little pre-demo, but he had to take off.
Wayne, how's your design coming?
Oh, it's going fine. I'm a little reluctant to show where it is right now. I'm having to reorient the sonars and all this mechanical stuff that I'm really not that good at. Okay, so I'm still working on that, but I'm actually making very good progress. I'm spending a lot of cycles on it. It just goes slowly because I have a day job now. So
very cool.
Mm-hmm. People can unmute if they want.
I didn't, yeah. So one thing that
I was just saying, I'm gonna drop off.
Mention
just do some work.
Hey, Ian, before you go, let me share an image.
Mach 3, and I said it has the 5.
Arthur, can I share an image?
It did it. Oops. Yes. Oh.
Well, my sharing's disabled.
If you look in their webpage for their company, they do have a contact me.
Let's see here.
I think you could see your screen.
Yeah, I'm not able to see the, oh, I know what the problem is. Bear with me. Yeah. I'll share it on the mailing list. Ian, join our mailing list.
Yeah, I was actually just doing that.
Super fine.
Cool. I'll look for it on there.
Yeah, nice to see you.
Yeah, great to see you guys. Have a good night, everyone.
Have a good evening.
Meeting you, Ian. Take care.
Oh, nice.
See that? You see that now?
Yeah, is that your robot?
Yeah, well, that's spring. That's Misty on springy thingy.
That's awesome.
Thank you.
Okay.
Con. Happy robots.
Lots of robots.
There you go.
Oh, it's Jane.
Yeah, it's spring.
All right.
That's awesome.
Where's Mark Johnston this evening? I don't see him anywhere. Hey, Dave Curtis, nice to see you.
I will unmute, but I have to stop typing if I do that.
So is my audio working?
We can hear you.
Hey, Bob, it's good to see that you're alive.
Hey, Ted. Yeah, you too.
Yeah.
Hey, Bob, are you sleeping?
Almost. Hey, Chris, it looks, you've got some good stuff going on. Looks good.
Oh, thanks. Yeah. The Super Anthony big biped.
Yeah, very cool.
Working on it.
Send us some more pictures and stuff as you get done, okay?
Okay. I
All
can
right.
only, yeah, I'm still working, so I'm doing like evenings and weekends. But the laser printer is really helping, so.
Oh, yeah. It's good stuff.
Your coffee shop maker space went out of business, Chris.
I know.
It's terrible.
The day job,
Yeah, I have to admit, it's nice being retired. I don't have to worry about that day job anymore. Ted dragging me through all the crap.
I was hoping that with coronavirus, I could since they don't know what I work on, I could get like a day ahead, and then I could do my personal projects during the day when I'm fresher, and then at night I could do the job.
Yeah, it never works out that way, does it?
It didn't. Yeah, people keep pinging me and.
Try to move to Mars time or something.
Yeah, I thought about it. I was trying to do it last week, but I just couldn't couldn't get ahead. I just ended up working more. Bummer.
Yeah,
Yeah.
good to see you.
Good to see everybody.
And then Shiloh, when are you coming home?
Who?
Oh, I was asking when Shiloh gets to come home.
Who?
Oh, maybe she's away from her headset.
Shiloh said she was going to go get some tea. So she stepped away. But no, Shiloh's going to hang out in Boston for the summer.
Oh, got it.
So the Shiloh lined up an internship at Robust AI and last winter, whatever. Then anyway, when this whole coronavirus thing came up, they said, "Well, we're going remote. Where do we send the laptop?" So Shiloh's just going to hang
Dan
out.
Albert out there.
Yeah. She can get all her work done 3 hours ahead of everyone else.
What's that behind you, Dan?
or sleep in an extra 3 hours.
Is that Karen?
Dan, we want a demo.
Turn off your mute, Dan.
Oh,
You're muted.
You're muted.
Dan, you're muted.
Am I unmuted now?
Yay.
Yay, that's Karen in the background.
The head's been upgraded.
Yeah, well, I'm in the next rebuild, so it's all she's just kind of hanging around for good luck.
We're all in the next rebuild.
Isn't that the truth?
Yeah, definitely trying to figure out what's going on here next. So I've Circuit Launch finally opened for members last week, members only. So I've actually been able to get back to my rover for the first time since like first part of March. Since the beginning of March, I got back over there the other day and made some repairs, fixed some things. You know, it took 2.5 months, but had it up and rolling around in Circuit Launch, which is pretty much empty at this point. A lot of companies are still working remotely. But I took it for a lap around the space. I had it running around and got it rehabbed and working in just a couple hours.
Take down all the walls.
They've done a bunch of internal, like I think because it was not a complete and total quarantine, like tape the doors and post guards and everything. They were able to have because there was some essential work allowed. They actually built up a number of offices and repositioned a lot of spaces so that they're socially distant and did a lot of internal reconfiguration. There are tables and chairs and meeting spaces around the donkey cart track. So because we're probably not going to be doing donkey car for a while there because they did kind of when they closed, they did kind of a stage closing starting in January where they put out like hand sanitizer and wipes and everything. And then the next thing after that was they stopped having meetups. And then they stopped having members members couldn't bring guests in. And then they just basically closed. So now they're kind of doing a reverse where members with key cards only first, and then at some point they'll allow business partners and people who aren't directly members or directly part of the community in, and then maybe, who knows, sometime end of the year, next year, you might have events like meetups or donkey car or things like that. But that's just so far in the future now. So So anyways, yeah, it was good to kind of get the robot rolling around again. And I'd say my big update is that I think at this point, if I were to stick with 3D printed everything on this particular robot, since I've been working on it for about a year, I would do as much nylon or carbon fiber nylon as I could, because everything else that I've tried is broken. Polycarbonate has broken, certain blends, a certain PETG, just I didn't even try that. ABS doesn't hold the weight of the rover. The polycarbonate that I tried, it snapped, the axle snapped before the robot even made a lap around the place. So that, whereas the Nylon X that I've been using and that I demoed a couple months ago, I think the last time we were at Google, and I actually had it rolling around, that was all on Nylon X. And so those have lasted a good couple months. They deflect and they bend a bit, but they hold up. Everything else just like snaps within 5 minutes, at least as far as like doing like structural, like axle and shaft support and things like that, load bearing things.
What's special about Nylon X?
Nylon is very tough and it binds, it has very good interlayer adhesion. If you print it at 100% infill, just the chemical, the nylon itself, it likes to like stick to itself. And then the X is carbon fiber. So it adds some stiffness to nylon, which can be kind of bendy. So it's, the long thin bits are really kind of a stretch for it as a material, but there's a lot of like demos, a lot like on the Matter Hacker site, there's a lot of demos of people doing like robo-car chassis, drone chassis, things like that. Skateboard trucks. They made actual functional skateboard trucks out of Nylon X. It's that it holds. So if you, I guess the thing is if you get this stuff in a mass, it has kind of like some chunkiness to it, like on a skateboard truck versus a thin shaft or something like that, it's practically indestructible.
Have you 3D printed your skateboard trucks?
No, because this stuff is kind of expensive and I wanted to use it for robot parts. But I would like to. I haven't had like the spare $80 to blow on, you know, experimental
I assume
trucks.
you have friends that have 3D printed skateboard trucks.
There was a project on the Matter Hacker site where that's one thing that they did was they 3D printed a skateboard, including the trucks, out of Nylon X, which is a super expensive way to do it. I 3D printed a camera crane, foldable camera crane setup thing for my action cam to go snowboarding with. So it extends out and there's like, you know, like a grip like for a selfie stick. That's also pretty indestructible.
Steve, okay, man of adventure.
Yeah, I think the next thing I'm gonna do is I'm gonna go back to metal for the structural parts. I've done, I think, sort of like my summary to the club on this, like 3D printing, almost entirely 3D printing your own robot is you can do it. You can do it as like a prototype and to kind of get things rolling and to do some testing and things. If you really, really need to get something on the road, it's not for like stems and axles and things, for anything that's not like a frame or big chunky structural support. It's not the greatest. You still want to use metal for a lot of things. But you can 3D print metal now, so that's the next step. Anyways, thanks for letting me ramble.
Hey,
yes,
Steve.
Sir.
You asked me a couple months ago, we were at one of the meetups and we were talking about the quasi-direct drive. And last month I showed you this particular one, which is the beta version. And they were in limited supply from the company. This is the company MJ Bots. And now they have them available if you want to buy them. They're, you know, if you're short on money, I would say you might want to wait because they're still $500 a piece. But they're
Yeah.
very lightweight, and very torquey, very torquey.
That looks really cool. I would love to check that out at some point. I am a little bit short on cash now. I had one contract that was going to be really nice with a robot company that was going to start up, but they it was supposed to start this week or next week, and they kind of pushed it off because of coronavirus.
Of course.
Yeah.
I've rewritten all the firmware on that, and I'm almost at the point where the motor. I mean, I can spin the motor, but
yeah,
I've yet to get the field-oriented control working correctly.
Uh-huh.
And I was somebody that wanted to work on the project with me that may have done that. Mostly because I'm working. I've got a paying client right now, and it's coronavirus, like you said, and they're letting me work out of the house, and so I'm taking advantage of that right now. But soon I'm going to want to get back on this motor because I'm very excited because finally we have a servo that can be used for robots that have arms and legs.
Yeah, and this is kind of another thing that I've started doing some research into is I think is quadrupeds. I want to finish my current rover and I want to get that like functional. But I think the next like build project I would like to do is I would like to do a quadruped. Like
this guy's got all the open source stuff. This guy's got all the open source stuff for a mini Spot, and he's got one working right now based on these.
I would love to build a Spot Mini.
Yeah, Spot Mini.
I have some remote work. I have some remote work that's been helping pay the bills. So that's been great. I've been doing some machine learning contracting, and that's all remote. So yeah, but I really could have used this. It would have been really great to get this other robot thing to kick off.
I'd like to take a conversation with you offline at some point about maybe using machine learning to teach and calibrate a three-phase synchronous motor, permanent magnet synchronous motor. I didn't know whether it was possible to do it that way. I'm thinking it might be a great way of spinning it.
We should definitely talk offline.
Yeah. Okay.
I have information relevant to your interest. Oh, other thing, one more thing. One thing I am doing is field testing a industrial grade vibration damped temperature temperature calibrated blah 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 industrial IMU and GNSS. So that was through a contact at Circuit Launch, who's also a member, but he runs them. So I have some microstrain IMU and GNSS positioning gear that I'm going to put on the rover and try that out versus the BNO 55.
Hey, Dillo, Dan, it's Ralph here, Ralph Nork. Hey, dial me in if you guys get talking about the motor controllers. I've been doing a lot of work with field control motor controllers that might be able to help. Nothing fancy like that, but just basic low-level programming of base vector and stuff like that. So.
You know what? That's we should sort of just maybe have possibly a separate meetup for that.
Sure.
Yeah.
Yeah. Which motor? I kind of missed it when you showed your motor there before, Dan. Which motors are you using?
Well, here's a picture of the. Let me just actually have another motor here. I'll unhook so that I don't rip all the wires out of it, as I usually do with most devices, because I'm a firmware guy. How firmware guys are with hardware. So this is basically a standard, pancake 24 pole pair motor. This is not exactly what's in this guy, there's a slightly different motor, but basically it's kind of the same idea. There's a motor controller, open source motor controller on the back, and you can buy this kit for relatively.
What's the
Sorry, say again?
processor? Does that come with source code and
it's
everything?
it's an ST Micro, yeah. So it's an ST Micro G4 series. I've written all of the drivers for the pretty much there's a chip on there's a TI 8323 motor controller. I've written all the drivers and got everything kind of up and running. I also have programs that monitor it over the CAN bus. There's a CAN bus on there. It's FD CAN, so it's pretty fast. And this controller here is the same one that is in this device here, which is why I'm still working on this guy, because I don't want to blow this one up. But I think that this will pretty much work with any, three-phase motor. You just got to define how many pole pairs there are and what, you need to have. This thing has an AMS position sensor on the back end of it. You can't see it. It's behind the board, and then the motor on the shaft of the motor.
Does it have hall sensors coming off the motor as well, or just use the AMS?
No, it doesn't use Hall. It has an AMS. It has the 14-bit absolute encoder, magnetic encoder. So
cool.
You get much more than a Hall. Trying to drive a three-phase motor with Halls is kind of difficult because you got to drive them trapezoidally initially just to get them to move until you can get a velocity reading. When then you can kind of estimate where you are in the grand scheme of things.
So
but this one actually it has much more control over it.
Okay, yeah, we can talk about it offline. Cool.
I have one more thing. I saw this. This is really cool. I wanted to bring it up at the meeting. I just put a link in the chat box to a company called botblocks.io. They make a product called Switch Blocks, which is a tiny little Ethernet switch. Like you could put it inside SmallCat, definitely inside my Rover, definitely inside some of like Motbot or some of these other things. It's tiny, but it's they're using the Ethernet 5 protocol, and it's they say it's 100 megabits and it's 5 ports. And I don't have the $100 to spend on it, but if I did, oh my God, I would have one like right now. It looks really, really, really freaking cool. I mean, like being able to do, imagine being able to do Ethernet in the size of full Ethernet inside your robot in a space the size of like a small USB hub.
That's a big advantage.
Yeah. So 100 mega, I mean, for like cameras or motor controllers or things like that, being able to do 100 megabits versus, barely a meg with TTL. I mean, I know TTL serial has gotten really fast these days. But yeah, so I had to put that into the chat because I think that's really, really cool. I think it could be like just a huge thing for, particularly like for cameras, getting camera data back to, your Jetson or Upboard or something like that. So I had to bring that up.
You mean, or your 5 cameras back to your Jetson board?
Or your 5 cameras. I mean, yeah, your 5 cameras, or your Jetson to your motor controller. I mean, imagine being able to like control your motor controller over Ethernet versus, SPI or serial, UART or something like that.
Didn't see Michael.
Like,
I
could
probably use that.
The response time you could get off of that would be. Anyways, yeah, 5 cameras, N cameras, all the things.
Hello, you should post that to the mailing list.
Okay.
Well, it's midnight here, folks.
Alrighty.
Really great seeing everybody. We'll see you next month.
Yeah, it's good to see you.
Okie dokie. Yeah, I'm gonna sign off. I'll tell you what. I'm gonna put my email address in. So anyone interested in motor control, if I can learn to spell. And then drop me an email, and we'll put something together offline. And you know, I'm willing to share my code. I have my code in a Eclipse. If people are familiar with Eclipse. And,
yeah. Unfortunately.
Yeah. Well, I don't know what else is better. You know.
for better or for worse.
I use IAR every day, and it sucks. So.
Hey Ed, you're late.
Yeah, sorry. Was busy.
It'll be on video.
Oh no.
All right, guys, I'm going to sign up and go get some dinner myself. So I'll talk to everybody later.
Karen's looking awesome back there.
All right, take care, gang.
The only girl in town.
All right, Ed.
When your only girl in town is your robot, that's what it is. My girl robot.
Sad but true. I feel better already looking at her.
All right, take care, gang.
Next time.
All right, guys, I'm signing off.
Thank you, Arthur. Thank you, Chris.
You're bye.
Later, guys.
We'll go ahead and shut it down for the evening.
All right, had fun.
Have a good night.
See you guys.